Okay, question number 17. Find the locus of a line which is equidistant from P 0, 1 and Q minus 2, 0. Okay, now the word locus means the path traced, the equation representing the path traced by the movement of a point. Means the equation representing the path as path traced by a point. You understand? So that's the meaning of locus. Like if you have a point here, and then you take a certain length about that point, and then you trace a path around that point, the equation of this line here becomes the locus. Okay, that's by the way. So now we are being given 2 points. We are being given 2 points. The first point is point P, which is 0, 1, in which here we can say that our x1 equals to 0, our y1 equals to 1. And then there is this other point, find the locus of a line which is equidistant. A line that is equidistant from these 2 points, let's call that line R of x, y, in which we don't actually know point. Then the next one is Q, point Q. This point Q minus 2, 0. So that means our x2 equals to minus 2, while our y2 equals to 0. So we have to find the locus of a line which is equidistant from these 2 points. So we're going to find the locus of these points. That's the equation representing the line traced by these points. But let's not just rush into calculation to further make this thing clarify. I'll just sketch the coordinate geometry to indicate this point so you can see the picture of what we are talking about. Okay. Now this is our R, x, y, and this is our point P, this is our point Q, and this place is our point R. So you see distance from, according to here, locus equidistance from point P, and that means from here to P is the same as from here to here. And we remember the formula. For calculating the length of a line in a coordinate geometry. Take for instance the formula for calculating line PR, that's from here to here. Line PR from here to here will be what? Square root of, since this is the first point, this would be square root of, that's this line from here to here. That'll be square root of x minus 0 all squared plus this other plus a second point, which is y minus 1 all squared. So this is the formula for calculating the length of a line. That's if it was in just a normal straight line, you just say r x2 minus x1 all squared plus y2 minus y1 all squared. So in this case, our x2 and y2 is, no, since this place is the first point, this is the second point, and this is the third point. So if we are to simplify this further, this will be x squared. X minus 0 is 0, so x raised to power 2 is x squared plus y minus 1 raised to power of 2. So if we also calculate the length of line QR, that will be square root of since this is the second point, that will be x, which is minus 2 minus x all squared plus the y, which is 0 minus y all squared. Simplify a bit. Minus 2 minus x all squared plus this will be y squared. So since these two lines, that's from here to here, that's QR and PR are the same. That means we can equate line, that means line PR is the same as what line, has the same length as line QR. So we take a new page to solve that out. Okay. If you have questions, you can do it through the contacts. You use my WhatsApp to ask so that I'll clarify anywhere you don't really understand. Okay, line PR equals to line QR. So when we start writing them out, that of PR is square root of x squared plus y minus 1 all squared. Okay, x squared plus y minus 1 all squared must be equals to QR, and our QR is minus 2 minus x all squared plus y squared. Minus 2 minus x all squared plus what? Y squared. And of course, these square roots will cancel these square roots. Although for the people who may not really understand, let's say you have square root of x equals to square root of y. Initial form, this is the same thing as x raised to power a half. It's the same thing as y raised to power of a half. If you square both sides, that would be x raised to power of a half squared. You find out this one will cancel this one, you'll be left with x equals to y. So that's by the way. So now the square root has been cancelled. You will be left with x squared plus y minus 1 all squared equals to minus 2 minus x all squared plus y squared. So we do further expansion to be x squared plus y minus 1 times another y minus 1 equals to minus 2 minus x times another minus 2 minus x plus y squared. So this is x squared plus y times y squared minus 1 times y minus y. Sorry, y times y is y squared, y times minus 1 is minus y. Then minus 1 here times y here is another minus y. Minus 1 times minus 1 will be plus 1 squared equals to minus 2 times minus 2 will give you 4, positive 4. Minus 2 times minus x will give you positive 2x. Minus x times minus 2 will give you positive 2x. Minus x times minus x will give you positive x squared plus y squared. So this is x squared plus y squared. This will be minus 2y plus 1 equals to 4. This plus this, that will be 4x plus x squared plus y squared. So if you take everything to one side, I'll take everything on this side to this other side. So we'll be having 4 plus 4x plus x squared plus y squared, then minus x squared. You know, this positive, you take it to this side, will become minus y squared. Minus y squared. This is squared. You take this one, that will be plus 2y minus 1. So you find out that plus and minus x squared will cancel, plus and minus y squared will cancel. You'll be left with 4 plus 4x plus 2y minus 1 equals to 0. So we write that out properly. You're having 4x plus 2y. 4 minus 1 is plus 3. 4x plus 2y plus 3 equals to 0. Okay, so our option goes to option A, which is our option A. So this is the equation that represents the locus of that point. So our option is option A. This is 2y plus 4x plus 3. And if you check, it's the same. 2y plus 4x plus 3. Just rearrange. Maybe in which if I stay, I can still rearrange it that way. 2y plus 4x plus 3. So this is how we solve that. Thank you.